Lesson 5.5, solving absolute value inequalities with a less than and a less than or equal to symbol. The essential question, what are the two types of graphs that may represent a less than or equal to absolute value inequality? To try to help you understand the effect that absolute value has on an inequality, I want you to imagine that you're standing on a number line, and I want you to think of how you could describe all of the points that are less than 2 units away from you on that number line. So less than 2 units away from you. Remember that absolute value is a distance, and we said distance is always positive back in chapter 1. The distance away from you could be to the right or to the left though. So what type of a graph is created if you graph these points? Well, if you're less than 2 units away to the right, I'm going to put an open circle 2 units away and connect it to my person. If you're less than 2 units away on the left, I'm going to do the same thing. So what is created? What is created is an interval that is 2 units away on each side of the person. So if an interval graph is created, that means that our compound inequality, when we're talking about absolute value with less than or equal to, the type of compound inequality that it associates to is an intersection. Or the key word between the two inequalities is going to be and. So what you should notice in this section 5.5 is that we're using everything that we learned in section 5.4. So working with compound and inequalities, that's what we're going to be doing in our lesson today. Now you may recall that an interval wasn't the only thing that could happen in our compound inequalities when we were working with intersections. So this next slide says, imagine that you're standing on the number line again. Now I'd like you to describe all of the points that are less than -3 units away from you. That might sound kind of weird. How can you be less than -3 units away? So think about what numbers are less than -3. So the numbers less than -3 would be -4, -5, -6, and so on. Those numbers are smaller than -3. So can you be less than -3 units away from something? Can you be less than -3 units away as a distance? Could you be -4 units away from something? If we start counting how many units we are away from this person on the number line, could that distance be a negative number? No. Distance cannot be negative. When you measure distance, you use a ruler, a tape measure, or something else that's similar to those things. None of those objects for measuring distance have negative numbers on them. So distance cannot be a negative. A ruler does not have negative numbers. A tape measure does not have negative numbers. If a distance exists, it is a positive. So sometimes we are going to have what we would call an empty set. And we saw that with our compound and inequalities. Sometimes our two rays, they did not intersect at all. So if they don't intersect, it's an empty set. Now, our homework problems are going to look more like this. The absolute value of x minus 8 is less than or equal to 2. I want to remind you that we learned how to solve absolute value equations back in chapter 2. Equations have an equal sign instead of an inequality symbol. And we learned that when the absolute value of x minus 8, when that was equal to 2, the stuff inside the bars could be 2, or it could really be a negative 2, the stuff that's inside of the bars. So we had to solve two separate cases to find two separate solutions because there were two different numbers that represented that same absolute value being equal to 2. So similarly, we are going to have two separate cases to solve here as well. Our two separate cases with our inequality are a little bit different. The first case looks just like the original problem, only no absolute value bars. The second case, though, says that the opposite of that x minus 8, so the opposite of that would be case 2. Now, the opposite is like multiplying by -1. And so we could multiply by -1 and distribute to case 2. I prefer, though, to divide by -1 instead, because if you divide by -1, you preserve the x minus 8 so that case 1 and case 2 look more alike. And the only thing that changes is the 2 becomes a -2, and this symbol has to flip, because if you multiply or divide by a negative number, it flips the symbol. So now look at our case 1 and our case 2, because this is what you are going to have to be able to do on your homework. You're going to have to know how to set up the problem. So if you're given the absolute value inequality, x minus 8, the absolute value is less than or equal to 2, you need to know how case 1 and case 2 are set up, and then you need to solve them both. So my first one, I solve by adding 8. The result, x is less than or equal to 10. The second one, I solve by adding 8 again. So x is greater than or equal to 6. If I graph these, my number lines would need to go from 6 to 10. The first one, in green, less than or equal to 10, is a closed circle to the left. My second one in red, greater than or equal to 6, is a closed circle to the right. So then their intersection, if I intersect these graphs, look at what they share. They share everything from 6 to 10. From 6 to 10. So 6 is less than or equal to x is less than or equal to 10 would be the inequality to describe my solution graph. So that is one way that you could solve this inequality. The other way would be to set it up as an interval. This is actually the way that I prefer, to set it up as an interval. Because you remember how I said, as long as we were keeping our inequalities, the x minus 8, as long as we're keeping that x minus 8 in both of our case 1 and case 2, that means that we don't actually have to write it twice. We could instead write it as an interval. So to make the interval, you take the 2 and you wrap it around, make it the opposite, and you have the same symbol, less than or equal to, on both sides. So it's up to you which way you want to solve these problems, because when you're working with less than or equal to, you can expect it most times to be an interval. I'll show you the exception a little bit later. So I'm going to show you that if I solve my interval by adding 8 in the middle and the right and the left, you actually get the same answer as you do with case 1, case 2, and it takes a lot less space. So it would be much quicker process if you write it as an interval and solve it as an interval. It's your choice. It's entirely your choice which way you want to do these problems. So you decide, but remember you are going to have to memorize all of this to be ready for the test, because there's nothing that's going to help you in this chapter on our formula sheet, nothing at all. So you have to be able to remember all of this inequality work, compound with and or, and the absolute values, without any help on a formula sheet. The second example, just like that first one, you can set it up as case 1 and case 2, or you can do the interval. So if I solve my interval first, add 5, so 2 is less than or equal to 2x is less than or equal to 8, and then divide everything by 2. I get 1 is less than or equal to x, is less than or equal to 4. So my graph would just go from 1 to 4, and it's an interval connected in between. The longer way, I can solve case 1 and case 2 separately. So 2x is less than or equal to 8, and divide by 2, x is less than or equal to 4. Case 2, remember, the opposite of 2x minus 5 would have the same absolute value as 2x minus 5. So if I divide away that -1, it means that I can flip and change, so it'll be greater than or equal to -3. Solve my 2 steps. So x is greater than or equal to 1. Now graphing these, remember from 1 to 4, I would need to graph them separately and look for where they overlap, what they have in common, because and represents an intersection. So my blue, less than or equal to 4. My green, greater than or equal to 1. And I can see that where they overlap is right here. So it's from 1 to 4. And I would still need to write the interval. So my interval is right here. 1 is less than or equal to x is less than or equal to 4. The second type is called an empty set. And what happens if we do the empty set, I will explain. My case 1 would look like this. My case 2, if I flip and change it, would look like that. So if I solve both of these, and I've got the word and in between, I can actually solve them at the same time, because I have the same action step. Look at my 2 solutions. So, if you think about the common sense here. Think about common sense. Can you pick a number that is less than or equal to 2 and greater than or equal to 12 at the same time? Is there a number that exists that is both of those things? No. So if you put these together for an intersection, they do not intersect. It's an empty set. Last but not least, in chapter 2, we talked about problems like this. A survey showed that 80% of young adults watch videos on YouTube. So this is going to be my 80%. The margin of error was 3%. What that means is that it might be 3 higher than 80. So 83% would be over here. Or it might be 3 lower than 80. So 77% would be over here. So when the margin of error is 3%, it means that it might not actually be 80. It might be 3 higher or lower than 80. So it creates an interval from 77 to 83. 77 to 83. So notice that in my inequality, and even on my graph, you don't have to have the 80%. We need 3 higher than 80, and we need 3 lower than 80 to describe the range. That's what margin of error means, that it could be actually a little higher or lower. And margin of error is really common when you're talking about surveys. It's really common. Okay, that's it. You should be able to write a summary now and work on your homework problems. The homework problems for this lesson are written on my calendar. And I will write them in here for you. So it's on page 312 and 313. Number 1 through 3, 7 through 13, 20, 36, and 37.